स्टार्टिंग करिए आती है उसमें कुछ कुछ करिएगा चेंज किया ना
साइज छोटे में बना
ये क्या हो गया नॉन प्रोबेबिलिटी सैम्पलिंग कन्वीनियंस सैम्पलिंग एक के ऊपर एक हो गया
कौन सी
दो तीन स्लाइड्स में सब है चलाती जाऊँ कुछ छोटे हो ठीक है जो सिर्फ टाइटल्स मिल रहा है ना ठीक है चलो ये पहले वाली स्लाइड पे चलो ये Good morning, dear learners. Welcome to teaching learning session. Today we'll discuss about sampling design. In our last lecture, we discussed about the objective, about how we find out our objectives, what are hypotheses. We discussed about the type 1 error and type 2 errors. Today we'll discuss about the sample design. What is sample design? What is sampling? Actually, first of all, it is very important to understand what is sampling, what is sample, what is population. Sampling, the process of obtaining information from a subset of a larger group. That larger group under study is known as population. Suppose you want to study about people who are in age group between 14 to 19, teenagers. You want to study about their eating habit of adolescents or eating habits of teenagers. So the teenagers of a particular area is your population. It's a larger group. While sample is subset of your population. When you choose some units from that population, those units are known as sample. How can you choose those units? That we'll discuss today. The result called sample are then used to make estimate of a larger group. Why we use subset or the sample? Why we choose subset or a sample? We choose subset or a sample just to make the estimate of the larger group. We want to find out the result. We want to generalize the results. Why we choose this subset? It is not possible for any of the researcher to study the whole population. It is really difficult, it is time consuming, it is costliest affair. So when we want to study a particular population, then we choose sample units. We choose the units from that population, and those units, those sampling units are known as the samples. Faster and cheaper. This sampling procedure, this study of the sample, that is generalizing the result or estimating the results of a larger group on the basis of a sample, it is faster and cheaper than studying the entire population. There are two keys while you are selecting a sample. Selecting the right people. It is very important. Have to be selected scientifically so that they are representative of the population. You cannot choose anyone for your study. If your population is teenagers, that is from 13 or 14, 13, let's, when we are saying teenager, so 13 to 19 year of age, then the person you are choosing as a sample for your study should fall under this category. If there is something else which you have specified for your population, then it must be there in that sample. So choose the or select the right people. You cannot take anyone. Oh, you are 19 plus, you are 19 and a half, will consider you under teen. No, 19 and a half means that population is not your population. That sample unit is not the perfect sample for your study. So choose the right people. It is very important. Selecting the right number of the right people. Then the most important thing is how many samples are required so that we can generalize our result. We'll take 100 samples. We'll take 50 samples for our study, 60 samples for our study. How we reach to this? How many numbers? What is the right number? Sample, what is the right number we should select for this study? It is very important. Why it is required? To minimize the sampling error. That is choosing the wrong people by chance. There is always a scope of error. Whenever we carry out our research, we carry out at 90% confidence level or 95% confidence level. Value of p is 0.05 or zero 0.1. What does means confidence level? Confidence level means there are 95% confidence level means there are 5% chances of error. Or 90% confidence level means there are the 10% chances of error, or 99% confidence level means there are 1% chances of error. So to minimize these error, we should select the right number of samples. How can we calculate the sample? Today we will discuss when we will discuss about the estimation of the sample size. Sample, contacting a portion of population, that is 10%, 25%, best with very large population and easiest with a homogeneous population. Sample is denoted by small n, and 10 to 25% is best with a very large population. When the population is very large, then the 25%, where you can take a sample of 10 to 25%. Or it is easiest with the homogeneous population. If population is alike, homogeneous, then it is easiest way. While census, the entire population, most useful is population is small or cost of making error is high, while population is denoted by capital N. Population versus sample. Population of interest is a bigger area. It covers a bigger area. It covers a bigger population or area, and sample is a subset of population. Right? We measure the sample using statistics in order to draw the inference about population and its parameter. We select the sample from the population. We measure the sample. We implement the sample. We measure the sample using statistics. And by this, why we measure the sample by using statistics, so that we can draw the inference about the population and its parameters, so that we can generalize our results, so that we can know about that population. Suppose I want to study about the food habits or eating habit of teenagers, or we want to know about the shopping habits of teenager. Our population, suppose the population under study is 1 lakh, and we have selected n number of samples from that population, that we will have to calculate how much sample size is required, right? Then we apply the various statistical techniques to inference about the population and its parameter, about to know about their eating habits or about their shopping habits. What are the characteristics of a good samples? It should be representative. It should represent the population. Means you should select the sample from the population, not from outside the population. It should be a representative of the population. Accessible. You can access them. And low cost. Cost should be minimum. Yes, population. When I said it should be from the population, then this is bad. When you select a sample, a few sample from the population and few from outside the population, it is not a good sampling technique. It is not a good sample. This sample does not represent your population. Population should be subset of, sample should be subset of your population. There should be no intersection. There should be no common area, but sample should be a subset of population. So this is bad, and this is really bad. That population and sample, if you take a sample from some other population for your study, then it is very bad. A right sample is sample should be a subset of your population. Right? You should select the sample. If you have selected, if you want to study the food habits of adolescent of a particular geographical area, that is, you want to study up the food habits of the children between the age group of 13 to 19, or shopping habits of teenagers, that is from 13 to 19, of a particular geographical area, say of Delhi or of Delhi NCR, then you should take this sample of 13 to 19, age group between 13 to 19, and should reside in Delhi or NCR. You cannot take a sample from somewhere else. Oh, you are adolescent, so what if you are not not residing in Delhi NCR? If someone is residing at Bombay and you are taking him as a sample, then that is not correct. Sample should be subset of their population. The entire group of people of interest from whom the researcher needs to obtain the information is population. Sampling unit, 1 unit of population. Each and every individual of population is 1 unit, and that is known as sampling unit of population. What is sampling? Selection of subset of the population. That is sampling. What is sampling frame? Listing of population from which sample is chosen. Right? You have to list the population from which you want to choose the sample. Census, the entire population. Survey of samples. Parameter, the variable of interest. In our example, the variable is, the parameter is shopping habits. It could be the food habits. Statistics, the information obtained from the sample obtained about the parameter. Right? Goals, to be able to make inference about the population parameter from knowledge of relevant statistics, to draw general conclusion about the entire body of unit. What is our goal? Why we are carrying out the research? The goal is to study the habits of a population, of a particular population, on the basis of the samples, and we can generalize the findings on the whole population. That is our goal, right? Okay, what is the critical assumption that the sample chosen is the representative of the population? We can only generalize our result if the sample chosen is representative of our population. Then only we can generalize the results. Steps in sampling process. There are few steps which one should consider while doing the sampling process. First of all, define the population. It is very important to define the population. Then identify the sampling frame. That is the list of the population from where you want to choose samples. Select the sampling design or procedure. And then determine the sample size and draw the sample. This is whole sampling process. Defining the population. First of all, define the population. Defining the population means you have to define a population. Suppose we have defined a population of a teenager of Delhi, right? Then again, sampling frame. What is sampling frame? As I told you, sampling frame, listing of population from which sample is chosen. That is teenagers of Delhi NCR. Listing of population, right? You should know how many. What is the population of teenagers or adolescents in Delhi NCR region, right? And then comes selecting a sample design or a procedure. How will you select the sample from your sampling frame, right? I'll discuss this, the sampling design, then determine the sample size and draw the sample. What is the sample design? The third step. What is the sampling design? First of all, define the population, sampling frame. We have defined the sampling frame. Now we have to find out the sampling design process, determining the sampling procedure. How can we take this sample from the population from the sampling frames? There are two ways we can choose the samples from the sampling frame. That is through probability sampling technique or through non-probability sampling techniques, right? Probability sampling technique. There are the ways or the type of procedures for probability sampling technique is simple random sampling, stratified sampling, cluster sampling. Non-probability sampling includes convenience, judgmental, and quota sampling, right? What is define the target population? What is the target population? Population under study is known as target population, right? Okay. Probability sampling. Let's come to probability sampling directly. What is probability sampling? Probability sampling is there is equal chance of each and every individual to be selected as a sample. Suppose there are 100. The population size under study is suppose 100. It's a very small, but suppose it's 100. Then the chances of selecting each and every individual as a sample is equal. The chances of selection of each and every unit as a sample is equal. There are equal chances of being selected as a sample. I can select A as a sample, B as a sample, or then D as a sample, or Z as a sample. The chances of selecting each and every unit as a sample is equal. That is probability sampling. That is the probability of selection of each and every unit as a sample is equal. There are four types of simple random. There are four types of probability sampling: simple random sampling, systematic sampling, stratified sampling, and cluster sampling. While in non-probability sampling, unequal chances of being selected as a sample. It is non-random. You could be a sample, maybe, but not so sure. The probability is unequal. The probability is unequal. The chances are not equal. Probability sampling when Each and every unit has same chance, equal chance of being selected as a sample. Non-probability sampling, when the chances of selecting as or selected as a sample are non-equal. That is non-probability sampling. Non-probability sampling are of convenience sampling, judgmental sampling, snowball and quota sampling. Probability sampling, the objective procedure in which the probability of selection is non-zero and is known in advance for each population unit. Means the probability of selection is non-zero. It is not zero. There are the chances that you can be selected as a sample. It is called the random sampling. Ensures the information is obtained from a representative sample of the population. Sample error can be computed. Survey result can be projected to the population and more expensive than the probability sampling. We can generalize the results obtained through probability sampling, while it is difficult to generalize the results of non-probable samples. Simple random sampling. The first technique of probability sampling is simple random sampling. What is simple random sampling? Population members are selected directly from the sampling frame. I have a list. Sampling frame is, in easiest term, what is sampling frame? It's a list of whole population. I can choose anyone as a sample. X, Y, Z, anyone. Suppose I have selected W as a sample from my sampling frame, right? There are equal probability of selection for every member from A to Z. Every and each individual has equal probability of selection as a sample. Suppose I have selected W as my sample, right? We use random number table or random number generator to select the sample, first number, right? N is the number of cases in sampling frame, that is, it represents the population, the total population. Suppose there are 1 lakh, the population is suppose 100. Let us start with a smaller number. Population is 100, so sample frames contain the n number of cases, that is the 100 cases. N is the number of cases in the sample, small n represents the sample, right? The number of combination of n from n is that each and there is a probability, equal probability of selecting as a sample, right? So sampling fraction is sample small n divided by the capital M. This is the probability. To select n units out of a population such as NCN is equal chances of being selected. I hope now this is clear. How can we do this? Use a table of random number, a computer random number generator, or a mechanical device to select as a sample. Okay. Selecting sampling designs systematic sampling. Okay. Suppose I want to select simple random sampling. I hope this is clear. How can I select a sample? There is a table of random number and I can choose any random number. A computer generates a random number and I can choose anyone as a sample. Suppose first I have selected W, then I selected A, then I selected Z, then the number comes out to be say X, right? Then there are equal chances, and the simple random sampling is there is a table of random numbers and a computer random number generator and mechanical device to select as a sample, and we select it as a sample. Next is systematic sampling. Another technique of probability sampling is systematic sampling. Systematic sampling is order all units in a sampling frame based on some variable and number them from 1 to 10. Right? Choose a random starting place from 1 to n and then sample every k units after that. Right? Suppose I have 100, the population size is 100, right? And in systematic sampling, order all units of sampling frame based on some variables. That is, suppose uh, population of 13 years age group, then 14 years, then 15 years, then 16 years, 17 and 18. Choose a random starting place from 1 to n. Choose any starting place. Choose the first sample randomly. One should choose the first sample randomly and then sample every k unit after that. Suppose I have all these numbers. I have this 1 to 100 as my sampling frame. N is equals to 100 and I want 20 samples of this. Right? What is the k number? K number is, I have to find out the k number. How can I find out the k number? K is the interval size. And how can you find out this interval size? That is total population divided by the number of samples required. That is, I have total 100 unit as a population. The total population is of 100 unit and I want 20 population, 20 samples. 20 samples, then 100 divided by 20 is 5. So the interval is 5. Interval size is 5. K is 5. Okay, randomly select an integer between 1 to k. 1 to k means k means 5. The interval size is 5. So randomly choose any number between 1 to 5. I have chosen 3 or 4. Suppose I have chosen 4. Right? Then first number should be chosen randomly. And then take every kth unit as a sample 4. Then come to the fifth unit. 1, 5th, 6th, 7th, 8th, then 9 should be my sample size. 1, 2, 3, 4. Right? If 4 is my sample size, then every fifth unit should be my sample. Right? Every fifth unit. 9, then 14 should be my sample size. Then 19 should be my sample size. Suppose I want 30. My sample size is 30. Then k will be 100 divided by 30. It will come out to be, say, around 3.3. Right? Means it will be again 4 or 3. Right? Right? Suppose it's 3. I have chosen any number. Suppose I have chosen number 2. Then number 2. Then if my k is 5, then the next sample should be 7. 7. Then after selecting 7, the another sample should be 11. Right? So this is the systematic random sampling. Place your or list your population in a systematic way, in some systematic manner. Right? Decide the number or the sample size. Try to find out the interval size. How can you find out the interval size? By dividing the population by number of samples required. Right? And select the first sample randomly and between the given interval, and then for next sample select every kth unit. Right? Next come it was we discussed about the simple random sampling, systematic random sampling. It was a random sampling, systematic, but it was a systematic random sampling. Next comes the stratified sampling. What is stratified sampling? The chosen sample is forced to contain a unit from each of the segment or strata of the population, equalizing important variable. Right? Suppose year in the school, geographical area, product use, etc. Stratified sampling means when we divide the populations into strata. That is stratification. We divide the population into strata. Suppose I want to take out the samples of a student of a particular school, then it is very important to divide the population of schools into strata, that is the students of age group between 3 to 6, then say 6 to 10, then from 11 to 14, then 14 to 16, then 16 to 18, right? It should be that there should be a strata should be there, right? Then population is divided into mutually exclusive and exhaustive strata based on appropriate characteristics. Mutually exclusive and exhaustive means one can be a member of one group only, cannot be member of more than one group. Suppose I want to find out the smoking habits of males and females. Then I divide the population under study into two stratas, males and female. Each and every individual of a population can either fall under the category of a male or a female. One cannot be member of both the groups. So each population, the population should be mutually exclusive and exhaustive, right? Simple random samples are then drawn from each strata. We divided this strata and then we select this simple, then through simple random sampling, we select the samples, right? List of the clients, then we have a strata and random sample, that is n upon n. Simple random sampling is applied, right? Population is divided on the basis of characteristics of interest population, that is male, female, or on the basis of age, on the basis of income, has smaller sampling error than the simple random sample since the source of variation is eliminated, and ensure representativeness when proportional samplings are used, right? Is this clear? So we discussed what is stratified random sampling, when we make a strata and we choose the samples from each and every strata. Okay. What should be the sample size of each and every strata? It depends on the, it is direct proportional to the stratified sampling. The sample size in each stratum is proportional to the stratum size in the population. If the population of one strata is say 50 or 60, then the sample chosen from that strata should depend on the population size, that is 60. If the population of another strata is say 200, then sample size of B would be chosen on the basis of the population, that is on the basis of 2, the sample is 200. So if it is 200, then the sample size depends on the number of, depends on the population size, right? If it is 50 and B is 100 or 200, then it is not necessary that you select 10 from A and 10 from B. If you are doing this, this is wrong. The chances of error increases in this. One should select the sample on the basis of population. It should be proportional to population, right? A disproportional stratified sampling, the sample size in stratum is not proportional to stratum size in the population. When should we use this? If strata are too small, some strata are more important than other, or some strata are more diversified than others. But one should go with proportional stratified sampling, is it is advisable. Selecting a sampling design, cluster sampling. What is cluster sampling? We discussed simple random sampling, stratified sampling, and systematic sampling. Now cluster sampling. Another type of probability sampling is cluster sampling. Cluster sampling, what is cluster sampling? Cluster of population of units are selected at random, and then all or some randomly chosen units in selected clusters are studied. Population is divided into mutually exclusive and exhaustive subgroups or clusters. Ideally, each cluster adequately represents the population. A simple random sample of few cluster is selected. All of some randomly chosen unit is selected clusters are studied. Right? What is cluster sampling? Cluster sampling is when we divide the population into exhaustive, mutually exclusive and exhaustive subgroups. Right? We divide each and every group as a, we divide it into a mutually exclusive and exhaustive subgroup. And each cluster represents the population, and from this cluster a simple random sampling should be done. When should we use stratified sampling and when should we use a cluster sampling? Stratified sampling, if primary research objective is to compare the group, if we want to know about the smoking habits of male and female, then go with stratified sampling. Using stratified sampling may reduce sampling errors. The error will be reduced. When to use cluster sampling? If there are substantial fixed costs associated with each data collection location. When there is a list of cluster but not of individual population members, then one should go with a cluster sampling. Cluster sampling is when you make a mutually exclusive and exhaustive population into subgroups or into one group, then that is known as a cluster. And you should go for a cluster sampling when there is fixed cost associated with each sample, and when the list of cluster is available but not the individual population member is not available, right? So, what is probability sampling? Probability sampling is where selection of each and every individual as a sample is equal. That is probability sampling. Probability sampling is of 4 types: simple random sampling, stratified sampling, cluster sampling, and fourth one is systematic random sampling, right? Non-probability sampling. Now, next type of sampling is non-probability sampling. What is non-probability sampling? Non-probability sampling is that is probability of selection for some population units are 0 or unknown before drawing the sample. That is the probability of selection as a sample is not equal. You can be selected as a population, but there are not equal chances. Maybe the chances of A could be more than the chances of B. When there is not equal chances, the selection of units are 0. Information is obtained from the non-representative samples of the population. Sampling error cannot be compared. You cannot compare the sampling error. Survey results cannot be projected to the population. You cannot generalize the results on the basis of non-probability sampling techniques, that the results cannot be projected to the population. What are the advantages of non-probability sampling? It is cheaper and faster than the probability sampling, and reasonable representative if collected in a thorough manner. Types of non-probability sampling. The first is convenience sampling. As the name indicates, convenience. It depends on the convenience of the researcher. A researcher convenience forms the basis of selection of the sample. If I want to study students, then I can select the people in my class. Male intercepts. I can interview anyone who is entering in the mall, right? So it is convenience sampling. Convenience sampling is where when the researcher feels convenient to collect the data. It depends on the convenience of the researcher. If I want to collect the data, uh, uh, if I want to study the uh, online shopping habits, right? Online shopping habits of males, right? Then I can go for the convenience sampling, or I can go with simple random sampling. If I go by the convenience sampling, then it would be difficult for me. It is not good. So if I go with the non probability sampling, then I cannot generalize the results. Suppose I have taken the data from my family members, from male members whom I know, with whom I feel comfortable, or with whom or I know I actually know about I have some idea about their um, shopping habits, and it will impact my results. It will prove my hypothesis. Then this type of a sampling is known as the convenience sampling, and you cannot generalize the results of convenience sampling because it doesn't represent the population actually, and you cannot compare the error. Next is judgmental sampling. A researcher exerts some efforts in selection of a sample, right? Seems to be most appropriate for this study. That is judgmental sampling is when the researcher feels like that X could be a good, more appropriate, could be an appropriate sample for my study. When I select X as a sample, right, and I feel like X is most appropriate for this study, then that is known as the judgmental sampling. It depends on the judgment. It depends on the judgment of researcher. The researcher could be biased while judging anyone. Next is snowball sampling. Selection of additional respondent is based on the referral from the initial respondents. Suppose friend of a friend. I want to study, or I want to carry out a study of the parents who have given birth to twins, or even more than one. Maybe I know only one or two who have given birth to the twins, right? Then I can ask them if they know someone else. They can refer me to someone else who have twins, right? So this type of sampling is known as snowball sampling, used to sample from low incidence or rare population. Quota sampling. What is quota sampling? The population is divided into cells on the basis of relevant control characteristics. The quota sample unit is established for each cell, 50 women, 50 men. The convenience sample is drawn from each cell until the quota is met. Suppose the population is divided into cells, divided into categories, right, on the basis of the relevant characteristics. Suppose male, female, right, smokers, non-smokers, drinkers, non-drinkers, and a quota of sample unit is established for each cell. I want 100 samples for drinkers and 100, suppose 100 for the non-drinkers, and a convenience sample is drawn from each cell until quota is met. I'll search for drinkers or the non-drinkers until and unless my sample size met, right? That is the quota sampling. Let us assume that you wanted to interview a tourist coming to a community to study their activities and spendings. I want to study the activities of the tourist, how much they spend, and what all activities they prefer, what in all activities they involve. Based on the national research, you know that 60% come for vacation, 20% for visiting of friends or relatives, 15% come for business, and 5% for conventions and meetings. You also know that 80% come from within the province, 10% from other parts of the Canada, 10% are international, a total of 500 tourists are to be intercepted at a major tourist place, right? That is from the spot of attraction, events, hotel, and other centers. As you would in a convenience sampling, the number of interviews could be therefore determined based on the proportion of given characteristics represent a population. Once 300 pleasure travel have been interviewed, this category would no longer be pursued, and only those who state that one of the other purpose was their reason for coming would be interviewed until these quotas were filled. So we have decided the quota, how much we require. What is the quota of each and every head, and then we carry out the interviews until and unless that quota has been met, right? Probability versus non-probability sampling. Non-probability sampling is less time consuming and less expensive because it depends on the researcher. It's a convenient sampling, snowball sampling, so it's less time consuming and less expensive. The probability of selecting one element over another is not known, and therefore the estimate cannot be projected to the population with any specified level of confidence. Quantitative generalization about population can only be done under the probability sampling. That you can generalize your result only on the basis of only about the population that you have studied through probability sampling. In practice, marketing research also applies statistics to study non-probability samples. Errors in survey. There could be the errors in survey, right? A random error, the sample selected is not representative of a population due to chance. It could be an error. The level of it is controlled by the sample size. The larger sample size leads to a smaller sampling error, right? So sampling error could be less. Non-sampling error. Non-sampling error, systematic error, the level of it is not controlled by the sample size. The basic type of non-sampling error are non-responsive error, response or data error. Non-responsive error occur when the unit selected as a sample of a sampling procedure does not respond in a whole or in part. If non-respondents are not different from those that did, the respondent, then non-response error. That is known as non-response error. That is non-response error is when you have selected someone as a sample and he or she has not responded responded to the procedure, right? That is the non-response error, right? A response or data error is any systematic bias that occurs during the data collection. That is a respondent error, that is lying, forgetting the things. Interviewer bias, that is the it is that it could create an error. Recording errors or poorly designed questionnaire could lead to errors. So, what is population? The What is population? The group under study is known as population. What is the sample? What is sample? Subset of the population is known as subset of the population is known as sample. Why is it required to select the sample? Samples are required so that you can generalize the result. The sample should be a representative of the population, right? Then comes sampling frame. What is the sampling frame? In easy word, it's a list of the population. It's the list of the population from which you can select the sample. Sampling procedure, there are two types. How can you select the sample? Through probability sampling. There are two techniques of selecting someone as a population: probability sampling and non-probability sampling technique. What is probability sampling technique? Probability sampling technique is that the chances of selecting each and every individual as a sample are equal, and non-probability, the chances are not known. It could be equal or it could not be. That is, chances are not known. Because chances are not known, then the you cannot find out the errors in you can in sample random, that is in probability sampling, you can compare the errors, you can find out the errors. Then the probability sampling is of four types, that is the simple random sampling, right? Then stratified sampling, cluster sampling, and systematic simple random sampling. Non probability sampling is again of four types. First is uh, another type of probability sampling is cluster sampling, five types of the sampling. Non probability sampling is your snowball sampling, quota sampling, right? Then comes convenience sampling, then judgmental sampling, right? It is very important to estimate the sample size. It plays a very
Sometimes,
important role. Why it is important to estimate the sample size? Because it minimizes the chances of error. We discussed about the errors, right? Error one, type one error, sampling error. Sampling error says you can control these sampling errors by selecting the right number of samples from the population. I have seen the students write the sample size for my study is 100, is 60, 50. When I ask them how you have calculated this sample size, they don't know. They said, as because we feel like 50 is more than enough, or 100 will do. No, there is a formula from which one should calculate the sample size, because otherwise there are the chances of error and the chances of error increases. Calculate the total population. When we sample size estimation for we calculate the sample size for known population and for unknown population. For known population is when we know the population size of the population under study, right? Suppose I want to calculate the sample size for a population of 1 lakh. The total population is 1 lakh, and I want to estimate what should be my sample size for 1 lakh population at 95% confidence level. Here it is very much important that you should know at what confidence level you want to find out the population sample size. Suppose I want to find out sample size of 1 lakh population at 95% confidence level, then there is a Solvins formula through which you can find out the sample size. Small n represents the sample size is equals to population divided by 1 plus population multiplied by margin of error square. Margin of error is 0.05, because at 95% confidence level I want to find out the sample size. So margin of error is 0.05. 5% chances are there that there could be an error. N is 1 lakh, I know, because population is known to me. I want to find out small n, that is the sample, and E is 0.05. Margin of error is 0.05. When I apply this Solvins formula, n is equals to n plus 1 plus population multiplied by E square, then population size comes out to be 399. That is 399 is the sample size, adequate sample size for my study. If the population size is 1 lakh, then at least there should be 399 samples. I should collect the data from 399 units, right? Okay. Now I have divided my population into groups, stratas. Right? When I was telling you the stratified random sampling, the strata depends on the number of samples, depends on the population of each and every strata. Suppose there are 3 strata, strata A, strata B, and strata C. right? And the population of strata A is 60,000, population of strata B is 35,000, and population of strata C is 20,000. So this is my population, but I have divided this into the stratas, right? The total population is A plus B plus C, that is 1,15,000. It comes out to be 1,15,000, right? When I do this, n comes out to be 399, but sample size should be 399. The total sample required for the three strata is 399, but how can what should be the sample size for group A, what should be the sample size for group B, what should be the sample size of group C? How can I divide 399? Can it be 100 or 99 or 100 no, I cannot do it like this. Then again, when I get the sample size, the total sample required is 399. Then I should apply the formula to find out what should be the sample size of each and every strata. That is, sample of strata A, Na equals to RPG multiplied by sample divided by total population. Matlab RTG means the total population of that group. The total population of group A was 60,000. 60,000 multiplied by 399 divided by 1,15,000. It comes out to be 208.17. It means the sample size which I should collect, the sample which I should collect from the strata A should be 208. NB, from the B strata, the sample depends on the population, and the population of B strata was 35,000. When I applied that formula, it comes out to be 122. Right? Sample size should be 122. And for the strata C, when I applied the formula, the population of the sample was 20,000. When I apply the formula, the sample comes out to be 69. And when you calculate that, 200 plus 122 plus 69, it comes out to be 399. So you cannot choose it randomly 100, 90, 100, 99, 100 or 100, 199. You should select or choose the sample on the basis of population of each and every strata. Never choose your sample size randomly or because you feel like on the basis of your intuition. It leads to the error, sampling error. And then you cannot generalize your result because your sample, there are the chances that your sample will not represent the population, right? So the sample size comes out to be 208, 399 plus minus 1, right? Is this clear? Infinite population. Suppose I don't know the population, I don't know the total population. That is, I want to carry out the study on infinite population. The total size of population is not known to me, right? Then there is coherent equation. You should apply this equation to find out the number of your sample. What should be your sample size? This formula is sample size equals to Z square PQ divided by E square, margin of error. What is N? N is the sample size. Small n represents the sample size. Z stands for the critical value of confidence level. There is a critical value of each and every confidence level. Whenever we carry out the research at 3 confidence level, at 90% confidence level, at 95% confidence level, and at 99% confidence level. So there is a critical value of each desired confidence level, right? Q is 1 minus P. What is P? Confidence level. P represents the level of confidence. Or the estimate proportion of an attribute that represents a population, that is assumed value is 0.5. We always assume the value of P as 0.5 and margin E is the margin of error. Value of Z, there is a defined value of Z that is at 95% confidence level, value is 1.65, 95% value is 1.96, 99 2.5. These values are given, defined values, right? Values of Z are given, that is the desired critical values are given. And now calculate the sample size at 95% confidence level. 95% confidence level N. Then the Z value at 95% is 1.96. 1.96 here multiplied by the value of P. We assumed P at 0.5. Q is 1 minus P. As it was defined here, Q is 1 minus P and assumed value of P is 0.5. 0.5 multiplied by 0.5 and margin of error is 0.05 because it is at 95% confidence level. When we solve this equation, it comes out to be 384.16 or 384, right? I hope this is clear. Similarly, you can calculate the sample size of infinite population at 90% confidence level, at 99% confidence level, but we usually carry out the social sciences research at 95% confidence level, but again it depends on the researcher. If you want, you can carry out the research at 90% confidence level and 99% confidence level. I hope now it is clear what is sample, how will you determine your sample, and how will you estimate your sample size. Each and everything is very important. You should not select sample like this only. If you want to generalize your result, it is always advisable to go with probability sampling. If you want to go with non-probability sampling, you can go with non-probability sampling, but then you cannot generalize the results of non-probability sampling. Non-probability sampling is loose type of a sampling because the chances of biasness is more in non-probability sampling and the chances of biasness is less in probability sampling, and you can control the sample errors in probability sampling while you cannot control the sampling errors in non-probability sampling. And then it is very important that you should estimate the sample size. There you can estimate the sample size for the known population as well as for the unknown population. Solvent's formula is there. You can find out the population size for the known population through Solvent's formula, and through coherent equation you can find out the population, the sample for the infinite population or when population is not known. Right? I hope this is clear. Right? Probability sampling, non-probability sampling. Probability sampling is of, again, let me discuss it with you. Probability sampling is simple random sampling, stratified sampling, cluster sampling, and another type of sampling is systematic random sampling. Simple random sampling, when you select anyone as a sample randomly. Simple random sampling. Systematic random sampling, there is a system. The first unit you select, the first sample you select randomly, then you select every kth unit. There is an interval size given, and then you select each and every sample with the help of that sample margin, right? Stratified sampling and cluster sampling. Non-probability sampling is convenience sampling, judgmental sampling, snowball and quota sampling. That's all for today. Thank you very much. Namaskar.